Okay, again today is the part 3 chemical reaction and equations. Okay, I said I have given you homework. Before saying that to homework, we'll go through the electrolysis of water clearly. So here material required is plastic mug, carbon electrodes, that is anode and cathode, 6-volt battery, rubber stopper, dilute sulfuric acid. These are the materials you require. Now step 1. Take a plastic mug, drill 2 holes at the base. Step 2. Fit 2 rubber stopper in these holes. Step 3. Insert the carbon electrodes in these rubber stopper. Step 4. Connect these carbon electrodes to 6-volt battery. Step 5. Now fill the plastic mug with water up to level that the carbon electrodes get immersed. Next, step 6. Add a few drops of sulfuric acid to this water. Next, step 7. Add a few drops of sulfuric acid. After that, take 2 test tubes, fill them with water. Invert these test tubes on carbon electrodes. Step 8. Now switch on the current from 6-volt battery. Next, what were the observations? So first observation that there will be the formation of bubbles at both the electrodes in the test tubes, which means gas is forming or liberating from water. Second observation is that due to the formation of bubbles, water will start moving in the test tube. Okay, next, after the 2 test tubes filled with gases, we carefully remove them out of the mug. Step 10. Test these gases one by one, bringing a burning candle close to the mouth of the test tube. What will happen? For results, when we bring a burning candle close to the mouth of one of the test tube, the gas in the test tube catches fire and burns with a pop sound, indicating that the gas in the test tube is hydrogen. And next, when a burning candle was brought closer to the mouth of the other test tube, the candle started burning brightly, indicating that the test tube contained oxygen. Next, the gas collected in anode is oxygen and the gas collected in cathode is hydrogen. See, when water it is passed electricity, it gives hydrogen and oxygen, and this oxygen is formed at anode and at cathode hydrogen is formed. This is very important. At anode which gas is formed and at cathode which gas is formed, and this diagram also very important. Now let's see why always oxygen is released through anode and why always hydrogen is released through cathode in electrolysis of water experiment. This was homework. I think most of the members have understood this, but I will say it again. As soon as you pass electricity to water, ions are formed, that is hydrogen and oxide ion. Which one? Hydrogen ion, hydrogen ion and oxide ion is formed. These are hydrogen is positive ion and oxygen, that is oxide ion, is negative. So what happens? Oxygen will collect it at the positively charged, because oxygen is negative and it is attracted to positively charged electrode, that is anode, and hydrogen will collect at the negatively charged electrode, that hydrogen is positive, it will connect to the negative, attract, that is cathode. So here opposite charges are attracted each other. Here sulfuric acid added because it helps in the water to form ions. The sulfuric acid is added because to form ions. It helps the water to form ions. So one you have to remember that ions will attract each other. Anode is positive, cathode is negative. So positive will attract negative and negative will attract positive. And here the important ratio is hydrogen is positively charged in H2 molecule, so it will end up with a negative electrode. So 2:1 is the answer. Next, next we are going to study about the displacement reaction. So I have said to by had this reactivity series. I hope everyone have by had this. Okay, next we'll go for a displacement reaction. Displacement reaction all depends on this reactivity series here, which is more reactive and less reactive. Displacement reaction is more reactive element displaces less reactive element. For example, here A is less reactive element and it is so A here is less reactive element. A and B. Now C is more reactive element. So here A and B is there. In this displacement reaction, it will C will displace A. That it will become CB plus A. So you can understand more better when I give examples. So here I written C can displace an element A from its compound AB. Just it is a single displacement reaction. Only single element is displacing. Okay, let's say the examples. So AB, see I have written AB in the A is less reactive and C is more reactive. So here C displaces A and brings CB plus C. Displacement reaction occurs. And here AB is more reactive, C is less reactive. Here the displacement reaction doesn't occur because more reactive doesn't end. It is more reactive. What is definitely more reactive element displaces less reactive element. Let's see example. So here iron and iron and it is copper sulfate. So let's see in the table where is iron. Ah, iron is here and copper is here. Which is more reactive than iron is more reactive, copper is less reactive. So let's go again to that. So iron is more reactive, copper is less reactive. Now iron can displace the copper, so it becomes iron sulfate and copper. So here single displacement reaction occurs in which only one element is displacing. Here zinc. Let's see for table. So zinc. So here zinc and copper. You can see, right? Zinc is more reactive and copper is less reactive. So here zinc can displace copper sulfate. It becomes zinc sulfate. And here lead. Lead, where it is lead? After iron. So lead is more reactive than copper. So lead can displace copper chloride. That is copper chloride. It becomes lead chloride plus copper. And here zinc. Here as this is formed, zinc sulfate is more reactive than copper, so no reaction occurs. Iron sulfate is more reactive than copper, so no reaction occurs. Zinc sulfate is more reactive than iron. See, zinc is more reactive than iron in the same way. So more reactive element displaces less reactive element. If more reactive element is already present, like this examples, then no reaction occurs. And next we go for few here I have bring some few examples for endothermic reaction. I had forgotten it. I said right I will say some easy equations for endothermic reaction. Here is some equations. I think this is also difficult. In most of the exams endothermic examples they did not ask, that is if they ask, that is the first one which I have given already. If you learn that one it is good. And these are few more examples. Okay, next we go for double displacement reaction. Here also same thing, displacement reaction. It will change its place, but here reaction in which there is an exchange of ions. Ions also will be exchanged between the reactants and called double displacement. And here in this reaction two elements are present. Two elements. Okay. For example, sodium sulfate when reacts with barium chloride, it gives sodium chloride plus barium sulfate. Two elements are there. So it is double displacement. In single displacement, only a single element will be there to displace. Here this is very important equation. Sodium Sodium sulfate when reacts with barium chloride gives sodium chloride plus barium sulfate. You have to balance this equation. And here some more examples, that is silver nitride when it reacts with sodium chloride it gives sodium nitride plus silver chloride. Again next lead nitrate when reacts with potassium iodide it gives lead iodide and potassium nitrite. And here next in this something called precipitation reaction is there, that is the insoluble substances formed is known as precipitate reaction. Any reaction that produces a precipitate can be called as precipitation reaction. So here see I have given sodium sulfate when reacts with barium chloride give barium sulfate and sodium chloride. In this reaction between sodium sulfate and barium chloride, here all the states will be in aqueous solution, and here the precipitate is barium sulfate. It is in a solid form and it is in a precipitate, so it is a insoluble substances, so it is a precipitate. So these reactions, double displacement equations, are always called as precipitation reaction. So this one topic concept is very important also. Next we are going to the next topic, that is oxidation and reduction. Here what happens, here there is a burner in that no, there is a tripod stand means three leg stand, and there is a burner under it, and there upon that there is a wire gauze, and there is a china dish kept upon that containing copper powder. Now what's it happens, heating a china dish containing about 1 gram of copper powder, what will be the observation? The surface of the copper powder becomes coated with black copper oxide. Okay, this is because oxygen is added to the copper and copper oxide is formed, and this copper powder is in a brown color, and when it is heated it changes into black color. Why? Because oxygen is reacted and it forms copper oxide. Copper when reacts with oxygen it gives copper oxide. Okay, next we'll go. See, I have written here the surface of copper powder becomes coated with black copper oxide. This is because oxygen is added to copper and copper oxide is formed. Here, see, I have balanced it. Copper when it is reacted with oxygen it gives copper oxide. Next here, what is the difference between the oxidation reaction and reduction reaction? So let's see. Oxidation, it is the addition of oxygen. Example here it is that copper when it is heated, that is oxygen is added. Okay, and removal of hydrogen is removed. And reduction is addition of hydrogen, just opposite removal of oxygen. See here I have given you example, Cu plus oxygen when it is heated gives copper oxide. And next magnesium, it is also oxygen is added, magnesium oxide. And reduction, here addition of hydrogen and removal of oxygen. Here see, in nitrogen hydrogen is added, it becomes ammonia. NH3 is ammonia and NH4 is ammonia, you have to remember it. And here redox action, both oxidation reaction and reduction occur together in a chemical reaction, and also this called as redox reaction. Here where is oxygen is occurred and where is hydrogen is removed, or where the hydrogen is added, so oxygen is removed. Let's see. So iron oxide when react with carbon it gives iron and carbon dioxide. So here iron oxide when in the RHS side it is oxygen is removed, that is removal of oxygen, that is reduction. And here carbon, and in next RHS side it gives carbon carbon dioxide. So this here addition of oxygen, that means it is oxidation. So here redox reaction happens. And next here also copper oxide, when reacts with hydrogen it gives copper plus water. Here copper it is reduced and hydrogen it is oxidized. And next same. And now let's see what is oxidizing agent, what is reducing agent. Now you understand which is reduction and which is oxidized, right? See here, copper oxide is oxidizing agent and hydrogen is reducing agent. What is this oxidizing agent and reducing agent? Oxidizing agent, it is which helps the other element to oxidize, and reducing agent is which helps the its element to reduce. So here hydrogen is helping copper oxide to reduce, so that is copper, and copper oxide helps hydrogen to oxidized in that same manner. So you can remember which element has oxygen you can call as oxidizing agent, and which do not have oxygen it can be called as reducing agent. Here iron oxide it is oxidizing agent and carbon is reducing agent. And here can you see which is oxidizing agent and which is reducing agent? That is hydrogen sulfide react with chlorine. Here is hydrogen chloride and sulfur. Here which is, first of all say which is oxidation, which is reduction. So here you have to not should see the oxygen, here you have to see the hydrogen. So hydrogen sulfide and sulfur, it is oxidation, that is removal of hydrogen, that is oxidation. And here chlorine, it is addition of hydrogen in the next. So that is, so here hydrogen sulfide is oxidizing it, so it's a reducing agent, and chlorine is oxidizing agent. And next about the corrosion we'll study in the next class. So I hope it is clear what is oxidized reaction and reducing reaction. If it's not clear, I will explain it in next class clearly. For now we will end up this session.